Merhaba, öncelikle hoş geldiniz. Bu sabah hep beraber, Elastic'le beraber Oredata olarak sizlerle hem teknik hem de kullanıcı tarafından deneyimlerimizi paylaşarak bir saat geçirmek istedik. Ben Özlem Kalkan, Oredata Satıştan Sorumlu Genel Müdür Yardımcısıyım. Oradata'yı kısaca hatırlatmak isterim siz katılımcılarımıza. Biz şirketlerin veriyi iş değerine dönüştürdüğü yolculukta teknik iş ortağı olarak çalışıyoruz. Bulut altyapısı, büyük veri, yapay zeka ve iş zekası temel uzmanlık alanlarımız. Aslında Türkiye'de kurulduk ama bugün hem MENA bölgesinde hem de Avrupa'da projeler yürütüyoruz. Ekibimizin büyük bir çoğunluğu mühendislerden oluşuyor. Bulut mimarları, veri mühendisleri ve veri bilimcilerden. Alanında çalışan sertifikalı, işin içinde olan insanlarız. Şirketimizin yaklaşık %85'i teknik arkadaşlarımızdan oluşuyor. Pardon. Teknoloji ortaklarımızdan Google Cloud, Cloudera ve Elastic'le Türkiye pazarında premium partner olarak, yani go-to market partner olarak çok yakın çalışıyoruz. Google Cloud'un Türkiye'deki tek managed service partneriyiz. Bu alanda 13 tane belgelenmiş Google Cloud uzmanlığımız var. Aslında bunu bir ünvan olarak değil de müşterimize karşı bir sorumluluk olarak taşıyoruz. Sektör olarak çok geniş bir yelpazeye de çalışıyoruz. Hem finans, hem telekom, hem e-ticaret, üretim, medya, oyun, enerji bizlerin güçlü olduğu ve Türkiye'deki bu sektörlerde hemen hemen o sektörün önde gelen tüm oyuncularıyla birlikte yol arkadaşlığı yaptığımızı söyleyebiliriz. Elastic'in de Türkiye'deki hem reseller hem implementasyon partneri olarak işbirliğimizi daha da derinleştiriyoruz. Bu webinarla da size aslında neler yaptığımızı biraz aktarmak istedik. Hem on-prem hem cloud müşterilerine ihtiyaçlarına göre hizmetler sunuyoruz. Elastic platformunun yeniliklerini, detaylarını birazdan İdo daha detaylı anlatacağı için o tarafa girmiyorum. Ama şunu belirtebilirim. Elastic kullanılan müşterilerimizle birlikte edindiğimiz çok önemli bir deneyim var. O da Elastic'i sadece doğru kurulması değil, doğru yaşatıldığı zaman değer ürettiğini görüyoruz. Biz de tam olarak o yaşatma kısmında güçlü olduğumuza inanıyoruz ve sizlere destek olmak istiyoruz. Health check'ten incident yönetimine, best practice'lerden rehberlik fırsatlarına kadar periyodik olarak sizlere bakım ve destek veriyoruz. Bugün de bu iş birikimimizi güncel bir yerden, yani Turkcell'le olan işbirliğimizden de nasıl hayata geçirdiğimizi ayrıca konuşuyor olacağız. Ama öncesinde sözü ben Elastic'in Solution Architect'i olan Ido Friedman'a vermek istiyorum. Kendisi birazdan bize öncelikle teknik olarak ve biraz Elastic'i tanıtacak. Sonrasında da bir demo gerçekleştirecek. Sonra tekrar beraberiz. Ido, the floor is yours.
Okay. Excellent. Thank you. So let me share my screen. We'll do a few slides, but the main focus is for us to see stuff in action and see the demo. Let me share my screen. Can you see my screen?
Yes, we can. Yes,
Perfect.
we can.
The slides, right? Perfect.
Yes, we
Okay.
have the cover page. Yeah.
Perfect. So let's start with a bit of an introduction of who is Elastic and a bit of what we do. So we are Elasticsearch, the company that was founded in 2012. We are currently about 3,000 employees, close to 4,000. We are a very, very common open source search solution. So you can see 5.5 billion downloads. We are at the top 10 downloaded softwares in the world. Very common for logging and a lot of observability as well as search. We are deployed in 40 countries between our employees and the company itself, and we have 1,500 global partners. We are being used in the top Fortune 500. 54% of them are being using Elastic. And we are traded as a public company in the New York Stock Exchange under this ticker. We have written here 300 turnkey integrations, but we actually have closer to 500. So it's a bit old. We have a lot of integrations and a lot of work we do to help our customers integrate their systems. So this is Elastic as a company. Just a bit of an intro of what we actually do in Elastic and what is the system itself. Our base is our search solution with all of the processing and all of the components around Elastic itself. You can see the different elements here, from ingestion to processing, visualizations, and storage, obviously. And we'll touch these in the demo today. In the background, you can see our solutions. We have two built-in solutions, which we'll touch today. We will touch the observability part. We also do security, SIEM solutions, as well as other areas in security, from EDR all the way to cloud protection. And we are still, as we started with the open source, we are still capable of build your own solution. So you see Elasticsearch here on the left. You can build your own solution, dashboards, and visualizations, and everything around it. So this is Elastic in a few words. For today's session, this is the agenda we would like to discuss. We would like to touch new stuff we've been doing in the last few years. We've invested a lot of time in optimizing costs and storage and the way we write data into Elastic. We've done a lot of optimizations there, so we'll start with that. And then we'll do two demos. One demo is around how to use AI. And as you probably all know, agentic AI is the way to do AI today. So we'll see a few demos on agentic AI in observability inside Elastic. And then finally, we'll do a quick demo on anomaly detection, which is a very useful utility inside Elastic. So that's the agenda for today. Let me just look at time, see we are okay. Okay. So we'll start, as I said, on compression and optimization for logging. Mainly, what you see here is logsdb, but we actually have the same concept for other types of data. We have the same for metrics as well. We will not be able to touch metrics today, but we can definitely touch that on further webinars. So logsdb is the main item for logging and optimizing the way we use disk. This is a part of a lot of changes we've made in the way we use resources inside Elastic. So let's review a bit of what we've done with logsdb. So first of all, logsdb is aimed at taking your logs in the same way you ingest them, in the same way you insert the data into Elastic, and basically optimize the way we write the data and take less storage while reducing the total cost of ownership with a few methods. You can see the different methods we've used here, and we are adding more and more. We are building the concept of how to use data in Elastic with more and more capabilities. The first thing you can see here is synthetic source. For people who know Elastic, we are taking the original data, original record, and putting that in multiple forms in Elastic. The main form is underscore source. So imagine if you have an event that came out of one of your servers or network devices or applications. We take the event as is and store it in Elastic. Alongside that, and this is the original source you can see here. Alongside that, we also do an indexed value, and we index all the data for fast search. And we basically, what it means is we store the data twice. What we've done in the last releases is instead of storing the data twice, we are actually using the indexed data once the data is inside, and you don't need to keep the original field. And by the way, you can choose to keep the original field if you want, original event, but it's optional. So if you are okay with just searching and seeing the actual data, but not the original structure of the information, you can use synthetic source, which saves a lot of this space. The reason we call it synthetic is once you query the data, we actually rebuild the original structure, we reconstruct it from the indexed fields and present it to the user. So if somebody is searching for a specific log event, he will be able to see everything that was inserted, but we don't need to keep the data twice. So that's a very significant change we've done with logsdb, but as you see, it's just the first one. Second thing we've done to optimize storage usage is we are doing smart indexing and smart sorting of the data. To who've done some compression work in the past, when you take two pieces of data that look very similar and put them together and do a compression on both of them, you get much better compression rates. So what we are doing is we are sorting by the fields of the log as it comes in. The default is host name and timestamp, but you can actually change that. The concept here, and you can see this in the diagram here, is we try to store all events or all logs or all metrics in a close area to each other. So host A will be close to host A, all the events. We try to do it as much as we can. It's not 100%, but this means we can get much faster queries as well as much better compression rate. So this is smart indexing. And again, all inside logsdb. So you just enable it and you get everything. Another thing we've added recently is we are compressing the doc value, which is the aggregative. You can see here the fields used for aggregations are being compressed once more. So you still keep the ability to do aggregations like what is the amount of logs I received from a specific host, but you still get all the details since the aggregation and the raw data is still there. So we do compression on the data that we allow for analysis and aggregations. And the last addition that was added, I think it was either last version or the one before, is log pattern optimization. It's a new type of data field, in which the concept of this field is we understand that most logs don't come just once. A lot of times you see the same log record or very similar log record coming at the same time. Imagine if you have, let's say, 10 applications that have a similar event, a lot of times you will get very similar log records. What we do in this case, we are looking for patterns in your log record. As you can see here, user 12345 logged into this machine with session ID. And what we do is we generalize this and we can store the patterns and the values separately, and thereby we can even further reduce the compression, increase the compression, sorry, and reduce repetitive values. The result of everything you see here is up to 60% less storage, which is quite a big number. That means that if you are using these features, you can have 60% less storage than not using logsdb. And this is right for metrics as well. In metrics data, we even get up to 80%. There is a minor indexing overhead, typically between 10 to 20% more CPU because we are doing the compression. But since CPU most of the time is not the expensive part, it's not a big impact on your TCO, and you benefit from getting the storage with a minimal impact on CPU. So that is logsdb with the goals of reducing the amount of storage we actually use on your system. And you can enable that very simply. It is enabled by default for all of our integrations. So for example, if you use a firewall integration like Checkpoint or Windows logs or application performance monitoring, which we will see very soon, it's all enabled by default. And fully compatible, and it will be used in this way inside the commercial version, and you can use that very easy. So that was logsdb. The second part of optimizing and working with Elastic and making things much more cost-effective and user-friendly is using our data tiering, and specifically the lower tiers of frozen and cold. You can see a diagram here that this talks about how data goes into Elastic and what happens in the data, and we'll do a very quick review on that. So on the left here, you have incoming data. Usually, if you look at most Elastic clusters, you have either hot data tier, and maybe another data tier. But in most clusters, you see only hot tier. What we are suggesting here is using more data tiers to have better retention, lower costs, and reduce the total cost of ownership even more. So the incoming data is always coming into the hot tier. Inside the hot tier, we keep two replicas, two copies of the data, primary copy and a replica for performance and high availability. So once the data is inside the hot tier, we usually recommend, by the way, SSD disks for the hot tier, so fast disks. Once the data is inside the hot tier, alongside the data that sits inside the hot tier, we also trigger snapshots as a backup. This is obviously not mandatory. You can choose whether you want to backup or not, but we are actually using the same snapshots and the same backup mechanism that we have inside Elastic to enable the other tiers that we will talk about in a second. Just before we go to the next tiers, you can also see here query SLA. We expect on the hot tier to have and when we recommend sizing, we recommend it for these query SLA. So common queries will be around 100 milliseconds and up to 1 second for most queries. So when we are talking about hot tier in Elastic, and a lot of time when we are being compared to other solutions, the hot tier in Elastic is very fast. It's aimed at millisecond latency and very fast results. A lot of times you will find solutions talking about hot, talking about seconds of queries. We are talking about milliseconds. And by the way, when we're talking about 1 second, this would be for the more advanced queries like aggregations on long time and stuff like that. Most queries will be 100, 200 milliseconds. Another thing you can see here is the RAM to disk ratio. The way we size Elastic is based on how much RAM is being used. This is the way we also provide the licenses. And the main aspect and the reason I'm showing this here is you can see on the different data tiers that we have from the hot tier going down to cold and frozen, we actually provision less RAM. So when the data in hot tier is landed in hot tier, we recommend 1 GB of RAM to about 30 to 80 GB of disk. When we go to cold, the ratio drops, so we have a lot more disk space for the same RAM. And the effect on this is that the query latency goes from milliseconds to a few seconds, usually 1 second to 10 seconds for most queries in the cold tier. So a lot of times you will see a configuration in Elastic where we have, let's say, 5 days in hot, another 10 days in cold, and the rest of the data can be in frozen. And as you can see in frozen, we have a lot more disk space and less memory, which obviously affect the cost significantly, and it's much cheaper to keep the data inside frozen. And you can see that the query latency, average query would be around 1 minute. So frozen for us is the archive, but it's an active archive. So when you do a query in Elastic, like you go to a dashboard and look at the data, you actually don't care where the data is. You just query the data based on the time you are looking for, and it will query all the tiers. It will all be automatic for you, depending on where the data lands. So it might be 5 days here, 10 days in cold, and 1 year in frozen. If you do a 1 year query, it will query the data from all the tiers. Beside the actual tiers, we have another very interesting mechanism in snapshots and backups, as I said in the beginning. So when the data lands in hot, we take a copy of the data and put it in a snapshot repository. Usually snapshot repository will be an object store like S3, but this is not mandatory. Any shared storage like NFS or any shared storage that can be a snapshot repository inside Elastic, and we support all types of file systems, object stores, even Hadoop can be a shared snapshot repository for us. So this is very, very flexible. In the cloud, by the way, you can use all the cloud vendors, so you can even use cloud just for the frozen and have everything on-prem. So it's very easy to do very complicated environments with very cost-aware environments. So what we do with the snapshot repository, once we do the backup is being used for multiple purposes. First of all, it's the backup for your data, and you do the retention as needed for the backup. Secondly, we have the cold and frozen tier using that snapshot as a copy of the data. So if in hot we have primary and replica, in cold we only have the primary, the second copy is actually the snapshot. So we even further reduce costs because we don't need to keep the data in Elastic. We actually keep it only on your storage. And thirdly, on the frozen tier, We don't keep any data. It's the data that is inside the frozen is only used for cache. We recommend a small cache that is SSD. On call, we recommend slower disks. So on frozen, we don't keep any data. All the data is on the storage. So this is more or less the stuff we've done for storage and optimization of the different data tiers and data that lands in Elastic. And this is a lot of these stuff are new stuff that are available in our commercial offering. But as we said in the beginning, we have three goals for this discussion. First of all is cost optimization and using our commercial offering to get lower cost of ownership. And the second item we want to talk about is AI in observability and do a bit of a demo. So let's go into that. The demo we're going to do, can you see my environment? The alerts and everything? Perfect. So the demo we're going to do a few demos if time permits for everything. The demo we're going to do is on application performance monitoring. I've got an application here with multiple services. We are using OpenTelemetry to monitor that data. It is an application being monitored by Elastic by collecting the data from the application itself. And you can see my page here with different alerts that was generated on that data. And you can see that the alert here are APM failure. APM is application performance monitoring. And as you can see, we have a failed transaction rate, which is higher than what we expect. You can see different ratios here, 68, 71. So high percentage of transaction failures. This application is written in different services. So you can see different services here, routers, proxies, trading application. It's a trading web application. And the interesting part here is I'm getting an alert. And what we're going to touch on the AI part is how we used to do alert root cause analysis and how we can actually use AI agents and analysis using AI to better understand that. So let's start with a quick intro on how we used to do stuff with just a bit of additional AI. So I've got these alerts in my Elastic, and imagine that this alert could have been sent by email, so you don't even need to go into Elastic. If I click on one of the alerts, and let's take the first one, I can see a bit of details. I've got an observed value of 68 errors, 68% of error rate in my application. What I usually do is, if I got an error rate, I need to go into my APM and look at the application. So I will click on View App. Click on View App, gets me into my service inventory. It will show me the information of my application. You can see this is a Kubernetes-based application. It's written in Node.js, and it is monitored by OpenTelemetry. I've got a lot of information from our APM here, but I actually don't want to go to too much details on the application because I want to go to the real stuff. So if I look at this, I can see that I actually have a high failed transaction rate for the last hour or two. And if I look at my transactions, I can actually see that the last transactions that are failing, and I see the failure transaction rate here is on this transaction. So I will click on this transaction to see what's going on here. And when I click on this, I can see again my latencies and throughput and stuff like that. I can see that my failure rate is very high here. And I can actually go and look at the information and the waterfall of what is going in my application. And I can see different elements of my application. I don't see my alert here. 1 second. I think I clicked on the wrong service. 1 second. Let me go back into my alert. Let's click on the service. View up. Okay, and I will go in again to my failure rate. So I've got 65% failure rate. And there we go. We got the errors themselves. So I can click on an error and I can actually see, sorry, you click on the right one. I can click on an error and actually see the details of my error. You can see here, view errors and view alerts. And I can actually see my error here. And I can start analyzing. I can see a constraint has been violated. And this is sort of how we used to do analysis of issues. We get an alert. we go and find where the alert affected, and we go and dig into details to understand what happened. But we are deep into the AI age, and we need to get some help here, and I don't want to do all of this digging myself. So first part of AI in Elastic, I can click on my alert here, and instead of me trying to understand what happened here, I can actually click on what is this error. This is a built-in integration inside Elastic that shows us and exposes the AI assistant inside Elastic. It will trigger an analysis of what happened here. It will also go into a lot of information capabilities, like going into my knowledge base. If I've got GitHub or issues and stuff like that, it can go and fetch information from other systems and explain to me and help me understand what happened here. So if you are looking at the result that we got here, we see a MySQL check constraint violation. So we see that on my MySQL database, somebody added a check constraint, and the service that we are looking at, this was the recorder Go service written in Go, is attempting to insert data, trade data, and it's got a 500 error. And I can actually look into more information, and I can see that it's showing me which table and what happened and the chain of events. You can see my service, the application name is Monkey, so I can see the way that the transaction got all the way down to my recorder Go service, and I can see the failure rate, and I can see a lot of information around this. I can even see open questions. Should I do this and should I do that? And a lot of concepts around how should I have a look at this information. So this is very, very basic AI. I basically get a chat that explains my error to me, and I can start another conversation and ask more questions. But when we're talking about agentic AI, we're not looking into just tell me what's wrong with my error. We actually want to get an agent that will go and understand what happened to my system. And if you remember, when I was in alerts, we had more than just one alert. What I've just done now is I went into a specific alert, just one of them, and I looked at the alert. I might have gotten some information there, but I only looked at one alert. I don't know if there's any relation between these alerts. So we want to get more out of just looking at an alert. For this, what we have is we have a full agentic system. And in this environment, what I've done is I've actually created a workflow. And inside Elastic, we have workflows. And you can see the alert process workflow. And this is a workflow that we have as part of Elastic. And it goes into your open alerts and tries to correlate data between different alerts. So I already ran it, as you can see, an hour ago on my alerts. And the result of the alert process is it's going to go on to and look at all of my alerts and try to analyze and give me root cause analysis. The way we do it is we tell the workflow, and we will touch workflows in a second as well. We tell the workflow, go and look at all the alerts and generate a case. Inside Elastic, we have a full case system that you can have alerts integrated. We have teams that can work on the case and put information and put some communication around what's wrong here. And my workflow that you just saw, it actually created this case for me. So let's go into this case. So this case was created about an hour or two ago when I ran the workflow. The actual content of the work of what you see here, the case, includes all of my alerts. You can see the 5 attachments. These are the alerts that we just saw. It was attached into my case, and an analysis. And what you can see here, first step is we see, instead of me looking at one alert in a time, we've got related alerts, all of the alerts together. So we can see the different services here. We have 28 transaction rate for these services, 29 transaction failure rate for these services, and another alert. So we get all the 5 alerts with a basic explanation on each of them. But this is not the interesting stuff. The interesting stuff is root cause analysis. So this agent actually looks at all of these alerts and creates my case, but it also gives me a summary of what happened. You can see the different services with the different thresholds. It actually draws a discovery and dependency map for my application. So you can see the different services where we had issues, which databases are here, and it actually goes into root cause and tells me what happened. So we have a database check constraint that was violated. So somebody added on my database some check constraint. It was violated on two services. If you remember from the beginning, I entered into one service and I did not have any correlation to any other services. So this already correlated both services for me. Once we got the constraint violation aggregated and understand that this happened in two services, we actually have details on these two services, and you can see the check constraints in everything here in all of the details. And now we actually want to understand what happened. And as I said in the beginning, we have inside the AI agent, we actually have a lot of data sources. One of the data sources that we added here is our GitHub. So the code for the application is available for the agent. And what you can see here is that it identified that the traces that came from this application was in version 09, and this version 09 is living alongside version 1. And we had bugs on version 09. You can actually see the information here. This information comes out of a known issue in our knowledge base. So when I asked the AI assistant to go and do RCA for me, it also goes to your knowledge base. It could be a ticketing system, it could be Jira issues, it could be a lot of systems that hold all sorts of data. But it doesn't matter where the data came from. It could be even an Excel file that you load into Elastic. As long as we have the information, we can correlate. And because we have the knowledge base, we understand that we might have some issues on version 09. The next thing we can do, and by the way, we can see that the monkey service is responsible for this, and it's failing, and everything around that. We have more information about what happened here. We have even remediation steps that can be taken. And one of the items that is being suggested here is have a look at pod logs and configuration for the monkey service and do some remediation steps. But again, we are at the AI age and we don't want to do stuff manually. So I can actually continue the conversation from my case. So I can click on this. And I'm going to use my AI agent. And what happened here is you can see the case ID. So we are doing an RCA on this case. I've got all of the information because I clicked on it. I've got all of the context already pushed into my AI agent. And let's do a question on two on what we have here. And a sample question that we can use is, if you remember, we had a few in the recommendation, we had a recommendation to look at my logs as well. So I can push something like this question. Was there a spike of logs rate when the issue started occurring? So I'm basically asking Elastic, go and check alongside my APM errors, did I have any log spike? Did I have any issues in my logs and stuff like that? So I can ask very generic questions and Elastic will go and search for the information and generate an explanation on what's going and what's working. Oslam, are we okay on time because we started a bit late?
No worries. Just a couple of minutes. It's okay.
Is it okay if I take up to 10 minutes to 11? Is that okay? Like 10:50?
10 more minutes, you mean?
No, not 10 more minutes, 6 more minutes.
Okay. We will be quick with Summit Bay. No
Okay.
worries.
Okay, so as you can see, I asked for check whether I had a log spike. So it was identified. Yes, you do have a log spike. We had a baseline of logs between this period. We had a deviation and there was brand new logs. You can see the deviation. So it actually goes and analyzes my logs. It will show you the services that actually created those logs, 25, 24 more logs on the Java service, 7.8 more logs on my recorder service. And it basically means that I don't need to go and find this stuff myself. I get a lot of information and a lot of knowledge. Again, we get the understanding of my service is an old version. Nobody renewed or entered the new version. So it might be related to this. So you can see that the log spike is related directly to the version here. And I can actually go, just because of time, we'll do just one more question on this. And let me just add this. We'll just do one more thing on this, and then we'll jump to another thing. So as you remember, we are talking about a case, and I'm doing an investigation. And because I've done additional information, I can actually ask the agent to go and update my case. So imagine you have two analysts working on it. One is asking question, another is doing some actual work, and you want to both of them to see the analysis. So I can ask my AI agent, go and update the case with the log analysis results. So somebody else goes into the case, he will actually see the results. And as you can see, it's going to execute that and do all the work on that. So while this is working, just because of time constraints, I want to show one other element of the way we do AI and introduce a bit of information about workflows. And we'll go back in a second to see the result then. So as part of Elastic, we have actually introduced a new workflow system, fully capable workflows. Everything you just saw was a combination with agents and workflows. So I can go into Elastic now and create workflows. As you can see, these are workflows that are created by YAMLs. The reason it is a YAML is for it to be code oriented. So you can have infrastructures, code concept, and manage your workflows in code. Another reason this is in code is because it's very easy to automate code today. So you can see a small icon here called AI agent. So I can actually use my AI agent to write my workflows. And let's take this example. I have a prompt that I prepared before. Once I click on the AI agent, you can see that my new workflow is already here inside, and I added this prompt. So let's create a new workflow that will be manually triggered and will iterate on open alerts, same as you just saw. For each, let me just click on this so it starts working. For each open alert, it will trigger a conversation with the Elastic AI agent to enrich the alert with more context, same as you just saw. And the output should be written to a new case that will be created for all of the open alerts in the execution interval. So I'm basically asking the AI agent, build my workflow. I don't care, and I don't want to understand how complex or easy it is to build workflows. We have a full authoring system for creating workflows, and it's analyzing my question, and it will start building my workflow, and you will see that in a second. While this is working, we can already go back into my conversation. This is my conversation. And as you can see, the case has been updated. If you remember from the previous conversation, I asked to update the case. I can now go back into my case. And I will see, if you remember, we had the initial analysis, all the related alerts and everything around this. And we have log rate analysis in the same case added by the agent. So everything we do is automated by the AI agents. And let's give this one more second to work. Depending on the request, obviously, and the LLM solution I'm using might take a few minutes. Let's give it one more minute. And by the way, you can have a look at all the process here. We have lots of tools and lots of information around our AI agent. You can actually use our AI agents inside Elastic or outside of Elastic. So it's a very flexible system. And as you can see, it's already generated what I asked. So I've asked for, let's create a workflow that iterates on my alerts. And it actually created the code for me. So you can see each green and red part actually added some information. So it added the description, manually trigger workflows. It changed my triggers from alert to manual. It went and did a query for Elastic Alerts and created cases. And for each case, it's going into an agent, calling the agent here and enriching the information. It's already extracted all the information from the alert. So basically what I need to do here is accept all and change the connectivity to the connector that I want, and that's it. I've got a working workflow that the only thing I used is natural language. I don't need to understand how to write that. So
Thank
this is the demo for today. Let me stop sharing and go back to you, Osman. And thank you
Thank
for
you very
that.
much, Ido. Just on time as you promised. So back to Turkish. Sorry for that. Ee, Şimdi sözü aslında asıl deneyimi yaşayan tarafa bırakmak istiyoruz. Turkcell'in elastik yolculuğunu bizimle paylaşması için bugün aramızda Samet Bey, Samet Özbay bulunuyor. Kendisi Turkcell'de Senior Expert olarak Service Reliability Engineer olarak çalışıyor. Yani aslında tam bu platformun sağlıklı ve kesintisiz çalışmasından sorumlu kişi diyebiliriz bence. Samet Bey, öncelikle zamanınızı bizimle paylaştığınız için çok teşekkür ederiz. Hoş geldiniz.
Hoş bulduk. Böyle bir imkan sağladığınız için de ben size teşekkür ederim.
Size birkaç soru sormak istiyoruz aslında. Hem Elastic'i henüz tanıyanlar hem de platformu değerlendirme aşamasında olan katılımcılarımız için çok değerli olacak bu
Hı hı.
yanıtlarınız. Böylece biraz önce dinlediğimiz platformun özelliklerini kullanan gerçek bir deneyimden dinlemiş olacağız. İlk sorum, öncelikle bu ihtiyacınız özellikle TV Plus tarafında olduğunu biliyoruz. TV Plus platformunda Elastic'e olan ihtiyaç nasıl doğdu? Hangi problemi çözmek için yola çıktınız?
Aslında bu soruya cevap vermeden önce benim Elasticsearch ile tanışma hikayemden kısaca bir bahsetmek isterim.
Çok
Elasticsearch ile benim tanışmam 2020 senesinde Turkcell'deki ilk görevime başlamamla birlikte oldu. Aslında bu noktada Elasticsearch Turkcell'de benden eski diyebilirim. Benim ama o zamandan beri olan gözlemlerim kapsamına cevap vermem gerekirse de aslında uygulamanın temel görevi diyebileceğimiz verilerimizi yani uygulama loglarımızı depoladığımız ve bu verilere gerektiğinde hızlıca erişebilmemiz adına arama ve analiz motoru amacıyla kullanıyorduk. SLA gözünden de baktığımız zaman bir uygulamanın servisinin o anda ne durumda olduğunu genel resmini görmek açısından veya bir kullanıcı deneyimini, davranışını incelerken de yine en değerli şey bizim datamız oluyor doğal olarak. Bu datayı da düzenli bir şekilde tutmak ve hızlıca ulaşıp üzerinde çalışabilmek de en temel ihtiyaçlarımızdan biri oluyor. Bu noktada aslında TV Plus gibi büyük ölçekli bir sistem yönetiyorsanız da Elasticsearch'te olmazsa olmazlarımızdan biri haline geliyor doğal olarak. Ek olarak Elasticsearch'ün esnek yapısını da kullanım tercihi olarak kullanım tercihini olarak tercih etmemizin sebebi oluyor diyebiliriz aslında. Esnek yapı derken de aslında onun da altını doldurmak isterim. Yani örneğin kolay ölçeklenir bir sistem olması, uygulamamıza gelen logların, servislerin artmasıyla birlikte bu loglar ve kullanıcı sayısının artmasıyla birlikte bir yandan da loglarımızın artmasıyla data boyutumuzun artmasıyla da bir performans sorununa yol açıyor olabilir zamanla. Bunu da yatayda büyüme olarak cluster'ımıza bir sunucu dahil ederek kolay bir şekilde yapma imkanı sağlaması da aslında bir tercih sebebi olarak değerlendirilebilir. Onun haricinde elastiğin yapısında şart yapısı var bildiğimiz üzere. Bu şart yapısının bize getirdiği kazanım olarak da düşündüğümüzde indeksleri farklı sunuculara dağıtan parçalara böldüğünden dolayı bizim aslında sunucular üzerindeki yük dağılımını burada bizim bu dağıtık sistemle dengelenmesini sağlaması da büyük bir avantaj sağlıyor. Yine aslında şart yapısının getirdiği başka bir bizim için avantaj da indeksler oluşulan şartların hem bir master hem de bir replikası oluştuğu için olası bir sunucu kaybı senaryosunda da bize aslında burada bir süreklilik ve o andaki veri kaybını önlemesi de çok bizim için avantaj sağladığı bir uygulama. Onun haricinde yine bir de Kibana hakkında ufakta bir bahsetmek istersem Kibana'da görselleştirme açısından kolaylığı ve çeşitliliği de bize çok yardımcı olmakta.
Çok teşekkürler. Aslında bir nevi şunu da bahsetmiş olduk. Kritik bir karar var önünüzde. Elastic'in genel özellikle söylediğinizde açık kaynaklı hani platformu kullanacaksınız. Platformu seçmenizde neden önemli olduğunu bahsettiniz ama en belirleyici ne oldu ve gerçekten iyi ki platformu seçtik ve sonuçları beklediğinizi karşıladı mı? Nasıl bir avantaj sağladı? Biraz da bundan bahsederseniz çok seviniriz.
Yani geçmişte biz aslında ekip içindeki farklı görevlere sahip sanal ekiplerimizde farklı ortamlarda loglarımızı tutuyor ve işletiyorduk. Farklı çözümlerle anomaly detection dünyasına da aslında girmiştik ama her geçen gün büyüyen sistemimiz ve buna bağlı olarak büyüyen datalarımız da bizi bir merkezi Elasticsearch ortamı kurma yönüne doğru götürdü. Bu noktada da merkezi elastik çözümümüzde Elasticsearch'ün platform kullanmaya birlikte machine learning özelliğini test ettiğimizde benim de aktif olarak rol aldığım bir POC süreci yaptık. Yaptığımız bu karşılaştırmalı testlerde de aslında Elasticsearch'ün machine learning özelliğinin hassasiyet ve anlaşılma noktasında öne çıktığını gördük. Diğer bir yandan da yine Observability çözümü olan APM gibi ileride entegre olacağımız özelliklerin de aslında daha çok bize faydasını görebileceğimizi fark ettik. Bunların haricinde de yine aslında bu kullanım sırasında dikkatimizi çeken yine özelliklerden bir tanesi de bize sağladığı işte e-mail'den Webhook'a ve Jira Teams'e kadar geniş bir konnektör desteğiyle sağladığı entegrasyonlar yine bize bir avantaj sağlıyor. Yani günün sonunda da biz zaten 6 adet fiziksel sunucunun olduğu bir cluster'da 70 adet anomaly job'la 56 terabayt bir data ile besleyip elastik dünyasının özelliklerinden faydalanıyoruz günün sonunda.
Eee, Bu anlamda evet, dediğiniz gibi, belirttiğiniz gibi anomaly detection ve ML özellikleri, yani özellikle machine learning özellikleri için en önemli konular olduğunu görüyoruz. Bu çerçevede bunu daha farklı alanlarda da kullanmayı düşünüyor musunuz? Size operasyonel olarak kattıklarıyla beraber yol haritanız nasıl? Bir onu da duyabilirsek, bu sürpriz bir soru oldu sizin için biliyorum, ama yine de bunu da bir duyarsak çok sevinirim kısaca. Kullanıcılarımız merak edebilir.
Tabii yani aslında değinmek istersem şöyle ekip olarak biz yani aslında kritik gördüğümüz ve anlık durum takibi yapmamız gerektiği her data için machine learning kullanıyoruz diyebilirim. Tabii burada en önemli şey data oluyor hali hazırda. Son yılların trendi olan yapay zekanın da en büyük ham maddesi data olduğu gibi anomaly detection'da da aslında en önemli kısım yine aynı şekilde data oluyor. Datamızı hem ham haliyle hem de manipüle ederek e, her türlü kullanabiliyoruz bu machine learning uygulamamızın üzerinde. Bu örnek vermek gerekirse belki bir sunucunun anlık memori tüketimi bile olabilir veya web servise yapılan bir isteğin response time'ı veya response koda göre bir machine learning cevabı bile olabilir. Bu noktada özellikle multimetrik anomaly detection özelliği sayesinde bir datada asıl etkilenen metrik ve bu etkiyi yaratan influencer'ları görebilmek bizim için fark yaratabilmekte. Bunu biraz da örneklemek istersek, mesela örneğin HTTP response kodunda yaşanan bir anomaliyi incelerken hangi sunucumuzun daha sebebiyet verdiğini görmek, sunucu bazı hata olasılığını direkt olarak bize gösterebilmesi bize sorun durumlarını daha hızlı root cause tespiti yapma olanağı sağlamakta. Bu örneği aslında bir adım öteye götürmek istersen mesela şöyle bir senaryodan bahsedebiliriz. 6 adet sunucumuzun olduğu ve aynı işi yapan bu 6 adet sunucunun bir yapıda çalıştığını düşünürsek bu 6 sunucudan 2 tanesine trafik gelmediği bir senaryo düşünelim. Bu noktada aslında dataya biraz da nereden baktığımız çok önemli. Yani trafik gelmeyen sunucularımda doğal olarak hata da olmayacaktır. Ama hata olmaması demek de her şey dört dörtlük, her şey yolunda gidiyor anlamına gelmiyor olabilir. Her ne kadar hata olmaması iyi bir şeyken de başarılı istek olmaması da o kadar kötü bir durum olabilir ki öyledir zaten. Bu noktada da yani eski klasik yöntemlerle monitörlük yaptığımız bir senaryo bu case'i kaçırma olasılığımız tabii ki de yüksek olabilir. Bu durumda belki servis ilk anda son kullanıcıya bir etki yaratmayacaktır. Hani 6 sunuculuk bir serviste 4 sunucunun hizmete devam etmesi ama diğer sunucuların da binen yükün artmasıyla birlikte bir girdap oluşturup tüm sistemin cevap verememesine kadar gidebilecek bir senaryo oluşturabilir. İşte tam aslında bu noktada anomaly detection özelliğinin asıl faydasını görüyoruz diyebilirim. Yani size var olmayan bir data hakkında da bilgi verdiği zaman siz oradaki anomaliyi görüp açıp bakıp aslında oraya gelmeyen trafik hakkında da bir root cause çalışabiliyorsunuz. Bu da bizim için aslında en büyük observability özellikleri kapsamında kattığı özellik diyebilirim. Son olarak da belki şeyden biraz bahsedebilirim. Farklı bir machine learning tipi olan categorization'da da aslında e, karmaşık paterne sahip log tiplerinde de logun paternlerini ayırıp kendi yarattığı kategorilere göre anomali oluşturması çok değerli bir özellik olarak görüyorum. Ve bu sayede düzensiz loglarla bile çalışırken çok rahat bir şekilde çalışma fırsatı sağlıyor bize. Yani kısacası Elastic'in içinde machine learning kullanırken ne kadar data sağlarsanız datanız kadar varsınız diyebilirim.
Çok güzel bir özet oldu. Çok teşekkür ederiz. Zaman kısıtından dolayı böyle manşetleri verdik biraz Samet Bey'le ama detayları merak edenler için ne zaman isterseniz bizlere ulaşabilirsiniz diyebiliriz. Bugünkü oturumumuzu burada sonlandırırken aslında öncelikle katılımınız için çok teşekkür ederiz. Şunu da belirtmek istiyoruz. Webinar sonrası bu oturumun kaydını, İdo'nun biraz önce paylaştığı demoyu ve sizlere olan sizlere özel bir deneme linkini gönderiyor olacağız. Sorularınız olursa isterseniz o paylaşıma cevaben de bize ulaşabilirsiniz. Bugün aslında sizlerle Samet Bey, İdo'yla ve Özlem olarak karşınızdaydık ama Elastic ekibinden bölge kanal ve iş ortakları lideri Tal ve Türkiye sorumlusu Elat da aramızda. Aynı zamanda Elastic ve Oredata'nın pazarlama yöneticileri Alexandra ve Nuran da aramızda. Onlar adına da hepinize katıldığınız için çok teşekkür ediyoruz ve güzel günler diliyoruz.